Are you ready for the next industrial revolution? Industrial 5G will change the way we make decisions, manufacture products, and maintain factories. In fact, it'll change the world. But what does that actually mean? What are the immediate benefits of 5G communication in a factory?
With 5G in factories, users will benefit from a robust wireless network, which will meet the industrial demands in terms of communication speed, real-time and security. All very important in industrial applications where downtime and failure is not an option. All of this in combination with the flexibility and mobility that comes with wireless.
And 5G is not a future technology, it's already here. Let's have a look at a real-life demo using 5G components from HMS and NXP. The user equipment in this demo is the Wireless Bridge 5G from HMS, based on NXP's i.MX applications processor technology. It is an Ethernet to 5G communication bridge that enables industrial machines or control systems to connect to a 5G network. The Radio Access Network, or RAN, is powered by the NXP LX2160A layer escape processor, which has the processing power and flexibility to run the Open RAN architecture, either as a 5G distributed unit or a centralized unit. In this demo, a distance sensor changes its state depending on the position of an object in the detection area. The sensor output is formatted as a secure OPC UA message and published to the server. Then these messages are transmitted via the HMS wireless bridge to the 5G small cell, where the baseband unit processes the data at layer 2 and 3. At the other end, the OPC UA client connects to the 5G core network using the N6 5G interface and receives the message to report when the distance sensor detects any movement. It's also possible to use Profinet over the 5G cell. To do so, a tunneling protocol is required to send traffic through the IP connection on the 5G network. 5G can also work with TSN Ethernet, providing similar time shaping and preemption capabilities.
The rollout of 5G has already started in small scale with test installations and proof of concepts. But as 5G and also the industrial use cases continue to develop, we will see a gradual rollout over the coming next years. But also, based on the values that 5G and wireless brings, we will most likely see a faster rollout compared to other communication technologies historically in the industry.
We have seen the first demonstrators, but there is 3 big vectors that we now need to drive, of course. Firstly, system cost. So it cannot be the task only to shrink big base stations and try to fit them somewhere into industrial footprints. We need to rethink system setups to make them attractive, also cost-wise attractive for small, medium enterprises. Secondly, we need, of course, to have an ecosystem support not only for installed big industrial equipment, but also for a variety of other participants, mobile robots, edge type of devices that are showing up in that communication ecosystem. And thirdly, privacy and security needs to be, of course, ruggedized and optimized. We, of course, need to make sure that this is all industrialization rollout ready, mass volume ready.
As these factors are coming into place, more and more industrial environments are looking into implementing 5G. But who will be first? Where do we see the early adopters?
Well, applications where the technology brings direct and clear values, like in industries with high flexibility demands, such in automotive, or in applications with challenging use cases, like in AGVs, material handling and mobile machines, all supported by the Industry 4.0 vision.
The semiconductor players, we are very active in this ecosystem. We are, of course, engaging also very closely in standardization activities and consortia like ORAN, 5G ASEA and others in that area. And of course, I'm particularly proud to have HMS here helping us driving the next steps in this ecosystem.